If you want a final year AI project that gives you real placement power, this is one of the strongest options you can choose. Because medical imaging is exploding in demand and companies are actively hiring students who can work with real diagnostic data. This project is called the Medical Image Classifier, and your goal is simple to understand but very valuable in the healthcare industry. You build a deep learning system that can analyze X-rays, MRI scans, or CT images, and automatically detect patterns linked to diseases. You train a model to spot issues like tumors, fractures, pneumonia, skin lesions, or diabetic eye disease. Hospitals are collecting massive amounts of imaging data every year, but radiologists are limited in number, so decision support systems powered by AI are becoming standard tools. That is why this project matters so much. Between 2025 and 2027, healthcare systems need faster and more accurate diagnostic help, and AI systems offer a scalable solution. When you work on this project, you learn how to apply computer vision to real medical problems, and you also understand how this technology improves patient care. Imagine an X-ray where a tiny abnormality is hard to see with the naked eye, but your model highlights it instantly. That is the kind of impact this project aims for. In real settings, these models are used in lung infection detection, tumor localization, skin cancer screening, and diabetic eye screening. To build a medical image classifier that actually impresses recruiters, you need the right mix of technical and domain skills, and this slide gives you the foundation. Your main tool is deep learning, especially convolutional neural networks, because they help the model recognize edges, textures, shapes, and abnormalities inside medical scans. Transfer learning becomes your biggest advantage, because models like ResNet, VGG, and EfficientNet already understand general visual features, and you only fine-tune them for medical images. This saves time and gives strong accuracy. You also learn essential computer vision techniques, such as preprocessing, normalizing pixel values, resizing scans, handling grayscale images, and understanding the basics of DICOM formats used in hospitals. Data augmentation is another key skill, because medical datasets are often small, so you create variations of images to make the model more robust. Your technical stack includes TensorFlow or PyTorch for model development, OpenCV for image operations, Keras for rapid testing, and MATLAB Fabless for visualizing predictions and feature maps. Beyond coding, you build soft skills that matter in healthcare AI, like understanding clinical terminology, knowing the importance of false negatives, and appreciating why interpretability tools, such as Grad-CAM, help doctors trust your model. Recruiters value students who can explain not just how a model works, but why a prediction matters in a medical context. When you start building a medical image classifier, you need a clear roadmap so you don't get lost in the complexity of medical data, and this slide gives you a practical plan that mirrors how real AI teams work. You begin by gathering a reliable dataset, usually from sources like Kaggle or public hospital repositories, and you prepare the images by resizing them, normalizing pixel ranges, and ensuring the labels are correct. Because clean data leads to stronger models, then you split everything into training, validation, and test sets to avoid overfitting. Once your data pipeline is stable, you move into the modeling stage, where you experiment with CNN architectures and apply transfer learning to speed up training and improve accuracy. You also apply data augmentation techniques, like rotation, zooming, and flipping to handle limited samples. After that, you fine-tune hyperparameters, track loss curves, and check model stability using validation sets. The next step is interpretability, where tools like Grad-CAM help you visualize which parts of the image influence decisions, making your model more trustworthy. Finally, you deploy the system by building a simple interface that allows users to upload images and get predictions instantly. Beginners usually need 6 to 8 weeks for the full cycle, while intermediate learners who already understand CNNs can finish in 4 to 5. This project creates strong career opportunities because medical imaging is one of the fastest-growing areas in AI, and companies want engineers who can work with real diagnostic data and support radiology workflows. When you complete this project, you become eligible for roles like medical AI engineer, computer vision engineer in healthcare, medical data scientist, or deep learning engineer for imaging solutions. These roles involve building diagnostic support tools, automating scan analysis, improving accuracy for radiologists, and integrating AI into hospital systems. Recruiters specifically look for people who understand CNNs, transfer learning, medical preprocessing, model interpretability, and the challenges of handling limited or imbalanced medical datasets. They also value familiarity with DICOM images and the ability to explain predictions clearly, because trust and transparency matter in clinical settings. Companies hiring for these roles include GE Healthcare, Siemens Healthineers, Philips Healthcare, Arteries, Cure.ai, and several fast-growing radiology AI startups. In India, freshers earn around 8 to 15 lakhs per year, and experienced candidates can reach 18 to 30 lakhs. In the US, salaries often range between $85,000 and $130,000 for entry-level positions. This project gives you credibility with hiring managers because it shows that you can solve real healthcare problems with AI.